Hi, this is Tom, and in this problem we're going to find how many ways to go from home to the coffee shop. Home is in the northwest corner and the coffee shop in the southeast. No retracing steps. The city is 3 by 3 blocks. So let's take a look at this. Let's make a block maybe about like that. So there's one, from there to there would be a block. There's another block. 1, 2. There's our city. It's 3 blocks, and it's 3 blocks the other way. 1, 2. And 3. So if I connect all these blocks like this, then this is the city that I have. It's a small town. So home is up here in the northwest corner, and maybe you have a little chimney. It's getting chilly out. And there's a fire. There's your door. And then you need to study, and your favorite place to study, at least one of mine, is if I can sit in a coffee shop. I love sitting in a coffee shop while I study math. So there's my steaming coffee. So I go from one cozy place to the next. Now, here's what I need to do. I need to begin at the house, and I need to end at the coffee shop. And so, for example, I could start out by traveling along this way, east, and then I could go south. Or what I could do is maybe I could go south, and then I could go east. Okay, but that doesn't really account for all the little blocks in between. So I'm going to erase that idea here, and let's start again. And I'll show you why. Because notice that these are in blocks. The number of blocks is important. So I might start out and go 1 block east. But then I could decide and say, well, I think I'll keep going east, so I'll go 1 more block east. And then I'll go 1 more block east. Now, I don't have a lot of decisions left, but don't think of it as one big long stretch south. Instead, it's 1 block south, another block south, and finally 1 more block south to get to the coffee shop. And look at what I've done. I have made arrows. These arrows are a way to encode the answers or the directions to where I need to go. For example, the route that I just wrote was right arrow, right arrow, right arrow, then down arrow, down arrow, down arrow. Well, wait a minute. Those are right arrows and down arrows. That is a word. And so I could say, look, there's if I count all of them up here, I have a total of 6 arrows, so I'm going to 6 factorial, but I need to divide by the fact that 3 of those are right arrows, so that's 3 factorial. And I have 3 down arrows, so I have another 3 factorial. And so when I do that, that becomes, let's work that out, that's 6 times 5 times 4 times 3 times 2 times 1 divided by 3 factorial is 3 times 2 times 1 times 3 times 2 times 1. And let's see, I'm going to cancel. Remember, you could do this in your calculator, and I'll show you that in a moment. And 3 times 2 times 1 is 6. And so it looks like, when we simplify all out, if you live in a 3 by 3 city, there's 20. That's right, 20 different ways that you could go from home to the coffee shop. Now, one other way to look at it is maybe you didn't like drawing arrows. Well, look at what direction did you travel. You also could have thought of this as well. I went 1 block east, then I went another block east, and then finally I went another block east. And then I started heading south, 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 and then south. Ease is what that word might say. And it might be easier if you had a friend visiting and they asked, well, how do I go from your house to the coffee shop? And you could give them directions in a block by block route. You could say, go east a block, east a block, east a block, south, south, south. Or you could give them different directions. I mean, you might send them on a different path. You might say you could go south 1 block, so you record that as an S. Then say go east 2 blocks, So I'd write east, east, and then you might tell them to go south 2 blocks, 1, 2, or south, south, and then you might from there tell them to head east. And notice that even though I took a green route instead of a gray route, notice that I end up with the same number of letters. There's 6 letters total in both of these. And let's see, 1, 2, 3, 4, 5, 6. And in both pictures, I have 1, 2, I have 3 S's, and there's 3 S's here. And I also have 3 E's, 1, 2, and 3. And so it's by doing that, just very simply, well, it's not simple. Actually, it's a difficult and fascinating concept when you realize that something so complicated as directions can be encoded as arrows or letters. But once you've done that, once you've understood the encoding, then you can simply apply your ways of counting words. And that's the key to all the problems in this section, is taking a word problem or a problem in words and encoding it into a mathematical word problem. Hope that helps. Thanks for watching.